Hey everybody, this is Alex Merced, and again, if you've been enjoying all these videos on data, please do like the video, subscribe to the channel, and leave a comment. Also follow me on LinkedIn and Twitter. But in this video, what I want to do is talk about two technologies, Apache Arrow and Apache Parquet. This kind of leads into the conversation from the previous video where we're talking about what is a data frame. So again, a data frame is just a columnar data structure that makes it much easier to do analytics. But we still have two problems. Okay, data frame by itself doesn't solve the following problems. Problem number one: loading the data from a file. Okay, so what kind of problems do we have when we're loading data from a file? So think about like your traditional files, like CSV files, which would be oftentimes a traditional way of just like passing data around, that comma delimited file. So again, I had an example of how CSV data would look like right here. Okay, the problem is you have to first read it as a CSV file, which means first you have to read the rows. Then convert into a data frame. So that means you have to kind of create all that array of columns from an array of rows. And that's going to require processing work. And for really large data sets, that might take a second. Okay. It can actually take a decent amount of time for a very large data set to have to convert all those rows into a columnar structure. Okay, on top of that, a CSV file has no schema. Okay, CSV file is just text. Okay, so we might be able to infer a schema and make maybe some programs might be able to do an educated guess and say, hey, these are numbers. That probably should be maybe some sort of integer field. Okay, those are letters, so maybe this should be sort of a text field. We could probably make some inferences, but still, again, that requires processing power. And if not, then I have to go back and then make sure that each column is of the right type. Okay, so basically I have two problems. Also, again, oftentimes, and then also just the size of storage, because CSVs are text-based. Okay, so even if we had like something like let's pretend we had like a columnar CSV. So let's imagine what that would look like. So maybe something like would look more like this. Let's see, let me create another text thing. Instead would be like instead of comma separated values, it would be comma separated columns or something, like a CSV. So it would be more like this. It would be like ID 1 name Alex Tony age 38 35. You know, that could work. You could theoretically do something like this and have a text-based columnar way of expressing columns. That you could do that. Problem is it's text-based. Okay. And text encoding takes up more space and is slower than possible alternatives. Because what happens when you have text files, what happens is that technically all the binary that represents all the stuff that you typed in there is encoded based on sort of a text encoding like UTF-8 or ASCII. So that means it has to read the bytes. So for UTF-8, it's 8 bytes per character, and it has to like translate that character to whatever the equivalent letter, number, character is, possibly even an emoji. Okay. So that means you have to use 8 bits per character. Now, theoretically, if we could come up with something that's more strict to a particular use case, you could maybe use less than 8 bits per character. That would require you to have to kind of create other parsers. Like you wouldn't be able to just open it up in Notepad and read the file like you can a CSV file. But the idea is that, hey, we want to solve these problems. We'd like to have something that maybe takes up less space, has a schema, so that way we know what the schema is the minute we read the file. And the data is already structured in columns, so that way when I load it up, I don't have to go then convert it into columns into a data frame. Okay, it's pretty much ready to go. It's pretty much in a structure that's ready to just translate into that. And this is where Apache Parquet comes in. Okay, this is a file type. Okay, in the same way you can save CSV files or JSON files or XLS files, this is a way to write the data to a file. Okay, a standard file type for saving analytical data. Okay, so now I could save the data that I need for analytics in a way that when I load it, it's going to load much faster. It's going to know my schema. Okay, just overall be better. Okay, so basically the way like a Apache Parquet file looks like, okay, just to kind of give you an approximation, essentially what's going to happen is that you will have row groups. Okay, so in this case, so here's one row group. Okay, and then each row group is going to be an array of columns. Okay, so in this case, we'll say like ID 1, 2. Okay, name Alex Tony. Okay, age 38, 35. Okay. And then we might have multiple row groups in one file. So let's say we have another row group. Okay. And here we may have, let's say, IDs 3 and 4. Here we have Bob and Susie, who are ages 40 and 45. Okay. So now then what's going to happen is that each row group is going to have a footer. Okay. Or a summary. Okay. So I might say, hey, this table, this row group covers ID 1 through 2, covers name Alex through Tony as a range. Okay, and ages 35 through 38. Okay, and then we'll have something similar down here for this row group that says, hey, this covers row 3 through 4. Bob through Susie is the range of values for the text field, and ages 40 through 45. Okay, so basically by having all this, again, so basically you still have the columnar structure, so you're still saving an array of columns, but you're grabbing a group of rows at a time and having summary statistics on each group or row at a time. Okay, now a tool that's running analytics on this file, when it loads the file, let's say I'm saying, hey, I want you to take this file and I want you to find me everybody who's in their 30s. Okay, before it even reads this, it can go read the summaries and say, hey, is there anyone who's in their 30s in this row group? Yes, we do. We do have people here who are between the age of 35 and 38. So I will read this row group into memory, and then I'll read the summary on this one and say, well, there's no one in the 30s in this row group, so I will not read this into memory. Okay, so in this case, it can more efficiently read. It can efficiently skip data that you don't need. Okay, that's important. So it's faster on a couple different levels. One, this is all written in binary, so it's not text encoded. It uses a binary encoding, so it uses its own custom way of sort of like representing all this information, so that we can do it in less space, and do it in a way that sort of maximizes its ability to use like compression algorithms and things like that. Okay, it's columnar. Okay, so basically the data when it loads, I don't have to really do a lot of work to convert it into a data frame in memory. And then 3, you have this metadata. So again, it's not the data that I'm looking for, but it's data about my data. That's what metadata is. So using the data about my metadata, I can scan this file more intelligently. And then this is also going to be, I think, a header that has stats for the whole file as well. So there's a lot of things you can do by using these headers and footers that are built into the Parquet file to more efficiently scan the file and only get the information you need. Okay, so overall, a lot better. Especially imagine when you're talking about like gigs and gigs and gigs of data. When you really out of that, a gigabyte CSV file is not going to be really efficient to scan, but a gigabyte Parquet file can be, especially if the data is really well sorted. So that way these row groups really kind of capture particular values. So that's what Apache Parquet is. So Apache Parquet solves the problem of, okay, having a good place to load our data from when we load it into memory. Now the next problem was problem number 2. Okay, in memory representation. So yeah, we knew that data frames are a better way to represent our data, but the problem is that everyone kind of had their own way of doing data frames and doing columnar structures in memory. So not just like, okay, how do you think about it from the point of view of programming, but also like how is that physically represented in the computer's memory? Like how is that handled? Like under the hood, how does that get organized in the computer's like processor and RAM for processing purposes? And everyone did it differently. So if I were to send a data set from one piece of software to another piece of software, I'd still have to convert it from this in columnar representation in memory to a different columnar representation in memory. So it made the data less portable. Every time you move the data, you'd have to kind of convert to that platform's way of doing it. So this is where Apache Arrow comes in. So again, the issue here is non-standard. It's non-standard. So that means when you move data around, there's a lot of serialization and deserialization. You have to convert it from one thing to another. Okay, which costs processing. So it's just, again, the idea is to try to cut out things that the computer doesn't need to do. So if we don't load up the data from a row-based file, then we don't have to convert it to columnar. And if we can stick to the same version of columnar data and the way we represent data in memory, or how we represent data in general, okay, then we don't have to convert it from one columnar format to another columnar format. Okay, and that just makes things faster because then we can skip those steps and focus on the actual processing of the data. Okay, so the Apache Arrow project did a few things. It created a standard columnar representation. Okay, and now basically even data frame libraries adopt this. So when you're working with libraries like pandas and polars, I'm pretty sure that they now do to some extent use Apache Arrow under the hood, so that way everyone's representing the data the same way. And then same thing, Apache Arrow has its own library for doing work with Apache Arrow structures. Okay, cool. So again, it created a standard columnar representation. And the thing is that created a custom way of sending that data across from one computer to another. Because oftentimes, I would get data from a database, and that database gets sent to my laptop. But then what happens, you would use something called JDBC or ODBC, which JDBC stands for Java Database Connectivity, which is a platform for connecting, an application to a database using Java. And then there was ODBC, Open Database Connectivity, which would be for all the programming languages. And you'd be able to connect to a database using an ODBC driver, and the driver would dictate how to talk to that database. These it was not, it's not fun to use JDBC ODBC because it's not like you just put in database credentials like using an ORM. What you have to do is you have to download a driver that actually dictates, okay, how to use JDBC ODBC with that particular database. You have to configure it, which usually requires you to configure some files, and then you have to accurately reference that file in your code. And little mistakes here and there, or in the configurations or whatnot, leads to a lot of headaches in trying to get it working right. Okay, and then replicating that on other machines, again, a lot of headaches. So, creating a better, so basically, and then again, when you use JDBC ODBC, it was row based. So essentially, even if the database or data warehouse or data lake house that you're connecting to sent the data over as columnar, it would first get converted into rows and then converted back into columnar on the other side, slowing things down. So the idea here is created a standard way to transport data. And this is what Apache Arrow Flight is. Okay, so Apache Arrow Flight gives a standard way to kind of send that data and keep it sort of columnar in the wire. So when we say over the wire, it just means like when you're going over the network from one computer to another. So it's going to be an Apache Arrow format from point A over the wire to point B. Cool. And this leads to much faster processing because again, you have a standard. You're dealing with a columnar format, which is going to be faster for processing. You're dealing with a lot less serialization and deserialization, whether it's in transporting the data or moving the data across different tools, because a lot of times nowadays we're working with multiple tools with the data. So overall, it just makes the whole supply chain much faster. Okay, so the idea is that if all your tools support Apache Arrow and use Apache Arrow, um, or very close to Apache Arrow constructs, the actual time you might spend serializing and deserializing between tools or across computers is going to be a lot less, leading to overall faster way. And also, Apache Arrow is a format that can handle uh, concurrency in the sense that, like, the way the Apache Arrow flight protocol works is that you could actually have it where, like, JDBC ODBC was built for like a single computer doing all the work. So the idea is I would connect to a computer somewhere, it would send me back the result. Like, it might use multiple computers behind the scenes to process the work, but everything I'm interacting through is through one server. And one server is going to deliver me the result. Now with Apache Arrow Flight, another cool thing about Apache Arrow Flight is that it does have flexibility for you to be able to work with in getting the results from multiple machines. Okay, so essentially the way it works is like you get under the hood, you get a ticket saying, hey, this is my little ticket telling me that, hey, look, I did a job. I sent a request for data. And when that data is available, I can take that ticket to different servers to get the different chunks of my result, which again can theoretically speed things up, because instead of me waiting for one server to collate and grab all these results, I could theoretically go back to these worker nodes and grab the data directly from them. Okay, instead of waiting them for the send it over to the main node and then send it over to me, I can go directly to the source. Theoretically, again, we're still in early stages with a lot of this. But yeah, so that's what Apache Arrow and Apache Parquet do. Okay, so Apache Parquet gives us a standard way to save the data in a file that's going to be really performant to load and efficient to read. And Apache Arrow is going to give us an efficient way to then take that data that we just loaded up into memory and work with it, leading to a much faster analytic story for any tools that use it. Okay, so nowadays most tools, I mean pretty much all data tools, allow you to read Parquet files, and more tools, tools like Dremio, are using Apache Arrow for processing. I mean, Dremio has been using Apache Arrow pretty much since its inception, because it was kind of started out as in part as Dremio's in-memory format, but it's now becoming sort of like the industry standards, like a lot of tools being built around it. So bottom line, these things are slowly becoming the way of doing things in data, and the idea is that everyone benefits from that, because when everyone plays by the same rule book, there's less conversions, less serialization, deserialization, leading to much faster performance. So hopefully this helps you understand sort of like what Apache Parquet and Apache Arrow is, because it's important in understanding sort of like how your data is being handled when you're working with it, with the tools that you're using. So see ya. Again, like and subscribe.